Let's look at number 9, and these are the notes that we're going to glue in. It says identify the key features, characteristics, features in the graph below, then give the value of each feature or characteristic. Y equals x squared. This is called your quadratic parent function. So this is the one that all the other ones come from. There's some kind of transformation that is done with it. The domain, and these have arrows on them. We're not stopping them. It just kind of goes off the edge. So go ahead and put your arrows on there. It doesn't have endpoints. It's continuing on. Domain is all real numbers because of those arrows. The range is our y values. So look at your y-axis. What is the lowest that it goes? 0, and then what does it go up to? Down to 0, up to infinity, right? So we need to write that as an inequality. We're going to write y in 0. Because we don't have two endpoints, we have the infinity sign. We won't have a compound inequality with two numbers on both sides. So are we going to say y is greater than or equal to 0 or less than or equal to 0? Does it start at 0 and go up, or does it start at 0 and go down? And go up to infinity. So that means it's greater than or equal to 0. Okay, do we have a minimum or a maximum now? Minimum. We have a low point. What is the lowest that it goes? 0. And then what is our vertex? 0, 0. It's a coordinate pair. Number of roots, 0 solutions. How many times does it touch the x-axis? Just that one time. And then our axis of symmetry, that's the dotted line that goes down. It's always written as x equals a number. What is x equal going right down the origin? Have to be 0. X equals 0. Then our y-intercept, where does it cross the y-axis? 0. 0, 0 again. And then numerical value of solutions. So the solution again is your 0, your root, your x-intercept. Where does it cross the x-axis? 0. So we're going to say 0, 0. Okay. Let's go to the next page now. We're going to go through some transformations. So the way we're doing transformations is you look at your parent function first. That's your original function. It opens upward. It has a 0, 0 vertex. And the minimum is 0. So we just got through talking about the whole parent function, but those are the key features of it. We're going to talk more about the vertex form tomorrow, but the vertex form H and K are it's your vertex. That's the point where it changes direction. So we're not going to do much with that right now. Okay, so all the different transformations are listed here. So the first one is a reflection. So we would say y equals negative f of x, means it flips over. It's a reflection across the x-axis. Or you could see it like this, which is still a reflection. Okay, vertical stretch and compression. Those are ones that a rubber band helps me explain better. So think about a rubber band. If I were to say vertical stretch, I would grab it on top and bottom, and this would be normal. But then when I stretch it, what do you notice about the rubber band? How does it change?
It makes like a triangle.
And it gets longer, it gets thinner, more narrow. That's what a stretch does. A vertical stretch, it makes it narrower. Or we could say skinnier. I think that's how you spell skinnier. So we're going to use our calculator to look at this. So go to y equals. We're going to put in the parent function. Just x squared. If you don't have your calculator, go grab it. And then we're going to look at the 2x squared. So we're going to graph these at the same time and compare.
Thank you.
So y'all got both of these in, y1, y2? The first one that's graphed is our parent function. The red one that I graphed is the narrower one. So we're just going to guesstimate what that looks like. See how it's stretched? It got skinnier. So when the number is greater than 1, like 2, 3, 2.5, 5, it's going to stretch it vertically. So that's vertical stretch. Then compression is going to be whenever you have a number between 0 and 1. So let's go back over here. And let's clear out y2. Now remember how to put fractions in the calculator? Alpha y equals, choose the first one. We're going to do 1/4 x squared. Hit graph. Well, how would we describe a compression on here? I would push it together. What does that do to my rubber band? Wider. So a vertical compression means it's wider. Or we could say fatter. Just like the rubber band. If I push it down vertically, it makes it fatter. Wider. So let's make a wider parabola here. We don't have to make it perfect. We're not graded on our graph today. We're just kind of estimating what it's going to look like. Okay, so the number in front of x squared determines either it being narrow or wide. Horizontal shift is the next one. What do you think +4 is going to do? Well, it tells you, but why does it say +4 but it goes left? So what we're going to look at is the number that's with the x. We're going to call it our crazy x. Think about an ex-boyfriend or girlfriend that you have. We would say that they're crazy, right? They did the opposite of what you wanted to do. That's why they're your ex. And hopefully they stay your ex, right? Don't go back with that crazy ex. If you don't have one now, hopefully you never get one. Let's put this in. So I'm going to keep y1 still my parent function. I'm going to put this in. X plus 4 close parentheses squared. So remember, it's the crazy x. It's going to do the opposite of what you think. Plus, I would think it would go right. But it's the crazy x. So where did it take us?
To the left.
To the left. Where do all their things go? Y'all heard that song?
To the trash.
To the left, to the left. Everything you own in the box to the left. No? Nobody? Nobody know? Isn't it Beyonce? Nobody listen to Beyonce? Nobody humors me. So sad.
I know this song.
All right. So then what would another crazy x that's a negative, it's going to do the opposite of what you think it does. So see how this shifts left? This one's the x plus 4 squared. We're going to go in and change this one to minus 2. Use minus, don't use negative. We're going to hit graph. It did the opposite of what we thought. Instead of it going left like negatives do, we went right because it's our crazy x. And where is it located? What's that point right there? 2. It's 2. Just like this number right here. So we're going to go to 2. We're going to draw our, this is the x minus 2 squared. So it does the opposite of what you think. Okay, and then the last one is a vertical shift. That's either up or down. So it's the number at the very end. It's the plus k. So plus 3. It's not the crazy x because it's not in parentheses with x. It does what you think it would do. So what is this going to do? Go up 3. So let's go ahead and graph it. I'm going to clear out y2. And I'm going to put in x squared plus 3. Now hit graph. And it went up 3. It looks like it's narrower, but it's not because it's just shifted. It's the exact same parabola. It's just shifted up 3. Then the other one, change the plus 3 to a minus 6. Where is that one going to go? Down 6. Hit graph. It went down 6. 1, 2, 3, 4, 5, 6. It's not wider. It's the exact same. Go ahead and glue this in.